So if you have already watched our previous talk shows, you will be able to recall that in peer-to-peer network, there are no single central authority who controls the network's operations. Because of this, each node here being the computer used by a participant in the peer-to-peer network, each node is expected to take proactive role in managing and developing the blockchain. In blockchain, we have something which is called miners. Miners refer to the nodes which create new blocks. Blocks here mean the records of all the transactions which happen simultaneously in the blockchain. These miners perform a very important work in the peer-to-peer network, because thanks to them we can always backtrack on any transactions and we can always check on transaction histories, etc. So, like for instance, who transfers cryptocurrency to whom and in what amount at what time. So we can verify and validate transactions. Yet, these miners work on a voluntary basis. So in order to motivate them to keep working, the peer-to-peer network has a mechanism called block reward. As its name suggests, block reward refers to new cryptocurrencies awarded by blockchain network to the miners for each block they mine successfully. So in a way, block reward is a strategy to sustain the operation of the peer-to-peer network. So now, in today's podcast, in order to understand more about block reward, I will talk to Blockchain Zoo CEO Roberto Capodieci, who will help us understand about the issue. So, good morning, Roberto.
Hello, good morning.
Yeah, so first, let's start with a basic question. What does it take for a peer-to-peer network participant to be a miner?
Yeah, the word miners has been coined for the Bitcoin blockchain, where the exercise to be able to confirm a new block, a new set of transactions. You gave a very excellent explanation, I have to say. Is between all the one that I see around is concise, precise, so very good. The miner is the account that can do whatever operation is required by the consensus system to confirm a new block. In the consensus system used by Bitcoin, there is an exercise of trial and error with a mathematical operation that is repeated many times until the correct result is found to be able to confirm a new block. This is why the idea is the one of the miners that go and keep hitting in the rocks until they find the diamond or the piece of gold or whatever they're looking for. In other consensus mechanics, the term has been changed. For example, proof of stake don't call them miners but minters, because they mint the block, or every consensus has its own words to distance themselves from the mining idea that Bitcoin has put in place. It's notable to see that their mining operations, they're not to be confused with the actual mining operation that they dig the ground, are a huge warehouse full of computers that do exactly this, trial and error of operation in order to find the correct result and bring the new block. One more precision, the reward that you mentioned in Bitcoin, and actually in all the blockchain, is called coinbase. It's called coinbase because if you take the Bitcoin blockchain, every coin has in history the start from the moment they've been created with a new block. So that's the base for the coin life cycle in the blockchain. Then a large company used this word, Coinbase, and became a big exchange, creating a huge confusion when people mention the word Coinbase as a function of the blockchain compared to the Coinbase, the company. But when you hear mentioning Coinbase in terms of a new coin generated at every block, then that's what is referred to the new coins created, not the exchange. There are also blockchains that don't create a new coin every block. Like most proof of stake blockchain tends to create all the coin at the genesis block, distributed in a few accounts, and then this account start distributing the coin to the new account that will open after the genesis block. So there are two different kind of way for setting up an economy. Obviously, the one that was thought for Bitcoin is the most adequate in order to distribute correctly, in theory, to all the participants in the blockchain the new coin. The idea was that one computer had one vote, had one chance, and in a network of thousands of computers, the new coin would go randomly to one computer, one account, or another. What happened though is that because this operation of trial and error rewarded the first to find the best solution to the mathematical problem, many people start using multiple computers for the same operation, speeding up the capacity to find it in order to collect the reward, creating huge warehouse full of computers and removing the chance from any other person that has just one computer at home to compete against them.
Okay, and I also have a question about the mathematical operation, because you mentioned several times, yeah? Because it sounds complicated in the blockchain transaction, because like the miners have to solve a mathematical operation to validate a transaction, something like that. So what's the mathematical operation, and then why is it so difficult or complicated, to solve transactions in blockchain?
So no, it's not for the transaction. This is just to chain two blocks one to the other. So in the moment that a new block is presented to the peer-to-peer network to be elected as the correct next block, it needs to contain a mathematical result that is calculated from the previous block plus a little bit of extra information that is added to get a particular result. Let me explain it more clearly. In mathematics, there is a branch of mathematics that is cryptography. One of the basic functions of cryptography is the hash function. The hash function is a mathematical operation that is an algorithm, not just an operation, that from a source data, a number, create a result that is a string always of the same length. So it doesn't matter if the input is just the letter A, is 0, is nothing, or is the full encyclopedia. The result is always 32, 64, 128, 256 characters, depends on the algorithm that is used, and is always the same length. It's impossible to reverse the operation, so it's impossible from the result to go and find the original piece of information unless I just try. So the idea is this, the operation is very fast on itself. So you take the previous block and create the hash of the block. So it's a string that is the fingerprint, if you want, the unique fingerprint of the previous block. Now, this is a very fast operation. So to create a difficulty in this operation, and when we talk about the hashing power of Bitcoin and the current difficulty, the difficulty is something that the consensus algorithm in the Bitcoin protocol, in most proof of work protocol, adds to the request of creating an hash. It says, okay, create an hash to validate the previous block, so when you post a new block, but you need to add to make sure that this hash starts with a certain amount of zeros. And to do this, the only option is to try to create a hash and see how many zeros there are at the beginning. Are there enough or there is none? Then add a little bit of data to the original block, create the hash again. And so this goes in many trial and error until there is an hash that has enough zeros to comply with the requirement of the protocol.
Ah, okay. Yeah, so now I understand how it works. And then what kind of activities specifically that miners have to do in order to mine a block?
So there is one container which is called mempool, where all the transactions posted by the users of the network are collected, waiting to be included in the next block. So if I am there competing with others to find the right block, I will choose set amount of transaction from the mempool. I can choose the oldest, I can choose the one that are paying a highest fee, which is usually the default function, or I choose the one that I want, it doesn't really matter. And I start creating, I add to this block also my address for the new coin to be sent to, right? So that's an important thing, as that was to make every block different from, let's say, two different accounts want to create the block, but the block they want to create has to have the address where the coin are sent. What people do is they start coming together, choose one address that they trust, and each one does a little bit of the operation for the trial and error, and all together go very fast in finding the solution. But pretty much created the block, choosing the transaction, adding whatever metadata, timestamp, etc., adding the account where to send the new coin. The next operation is the one to finding an hash for this block, which includes the block, also the hash of the previous block, obviously inside, in order to chain them. Created a new hash by trying to add a little bit of that, a little bit of that, a little bit of that, until there is a hash that starts with 00000 enough 0 to comply with the current difficulty of the blockchain.
Okay.
One thing, sorry, I would like to add.
Yes.
The pools of which blocks are created in the Bitcoin blockchain is one every 10 minutes. So in order to guarantee that they don't get produced too fast or too slow, the algorithm automatically adjusts the difficulty once every 2 weeks, I think, circa in time, once every certain amount of blocks, so that the current difficulty is the one that, based on the capacity of the computer to do this trial and error, will take them 10 minutes to create the new block. What this means? This means that if before somebody had two computers working together to do this trial and error, splitting half of the work in a computer, half in the other, to go twice the time, as soon as it does it a few times, the algorithm adjusts, doubling the difficulty, so that two computer is gonna take 10 minutes. So this person will put 4 computers, and 4 computers in order to be the first to find the solution. But then the algorithm adjusts to make 4 computers take 10 minutes, and so on. So what happened, the grid of people to collect these rewards makes such that you need thousands of computers to split the problem a little bit each in order to find the result, leaving people with one single computer in the impossibility to compete with them.
Oh yeah, so like it's a system to prevent people from infinitely collecting the rewards, yeah, or...
It will search the most powerful computer in the network in this way, but the developers that taught this consensus mechanics, or the developer, Satoshi Nakamoto, never thought that people would split the problem in multiple computers or come together and divide the problem between many users in a pool. That's why, and he also actually wrote this in an email himself. That's why the flow in the mechanics is bad, because he created all this complaint about electricity consumption that is insane, etc., etc. The difficulty never was meant to become so high as it is now if people didn't split the problem among multiple computers, but were just using one computer per account. It would be very low difficulty, no electricity consumption, but...
Yeah. And on average, how many hours a miner spend, in like one mining activity?
No, it has to happen below 10 minutes. So
Okay,
the difficulty is always regulated, so that in 10 minutes there is new block that is found. Then the
Okay.
game starts from zero again
Ah,
for the
yeah,
next
yeah,
block.
yeah, yeah. So how many blocks can one collect in a day or?
Well, you calculate one block every 10 minutes, so in 1 hour there are 6 blocks in average. So in 10 hours there gonna be 60 blocks, 120, 132 blocks per day. Right?
Yeah, it depends on like the time they spend on their computer, obviously. Yeah, yeah. Okay. So like usually what motivates someone to be a miner?
Yeah, the only motivation to be a miner is the value of the cryptocurrency, because that's what is the reward, right? So every new block at the beginning of the Bitcoin blockchain was giving 50 new Bitcoin to the account that was finding the red block. So every 10 minutes there were 50 new Bitcoin put in circulation. After several years, this has halved and became 25, then became 12 and a half, then became 6.75, and which is the current amount, I think. And it's gonna go half and half and half and half forever until the reward is very little. At the point, probably miners are gonna move to mine a new blockchain that is gonna give them more value, unless the Bitcoin value is gonna go to the millions of dollars. So even a small percentage. Consider that at the time the 50 Bitcoin were given, the value of one Bitcoin was $1 to $10. So now that the value went up to $60,000, obviously, even if rather than 50 you get 6, we'll get way more money in terms of value. Plus, there is not only that. The miner collect also the transaction fees. So when a user posts a transaction in a blockchain, they pay a fee for their own transaction. These fees are collected by the account that create the block. This is a Bitcoin blockchain, because there are other blockchains that work differently, I have to say.
Yeah, and then like the cryptocurrencies values keep on declining. Is it because of the law of diminishing return? Just like
the value of the cryptocurrency change based on market
yeah.
or other things. There's nothing to do. But what is true is that when the value of a cryptocurrency goes too low, then miners stop mining for that one blockchain and they move their mining power in another blockchain, which give them more value.
Okay.
So the choice has all this hardware set there to do this mining operation, which means the trial and error for the result of the creating new block, can choose what blockchain they do the exercise for. So if the exercise is done for the Bitcoin blockchain, then they're gonna collect the reward, the coinbase of the Bitcoin blockchain. If they do it for Ethereum Classic or for Ethereum, they collect Ethereum Classic or Ethereum coin. If they do it for some other, wherever is compatible, the algorithm that they can calculate, they can move the hashing power from a blockchain to another.
Okay. And how much is a miner rewarded for the block that she or he has mined? Like,
yeah, that's what I was saying. The reward, the Coinbase changes based on the blockchain, based on many other specifics. But in Bitcoin blockchain is a certain amount of Bitcoin. It started with 50, then it went 25, 12 and a half, etc., etc. But in other blockchain may change based. There are blockchain, for example, Bitcoin has a maximum of 21 million Bitcoin they're gonna be ever created. So once that amount is reached, there is no more Coinbase. It's only transaction fees that are collected. While Ethereum started with no limits. So started that you can create an unlimited amount of Ethereum. So those are different things. So it doesn't have to halve the Coinbase, etc., etc.
yeah. And what's the difference between block reward and proof of participation?
Proof of participation is a different kind of consensus. So you have a proof of work, a proof of stake, etc., etc. The block reward is present in several different blockchains. So while proof of stake mainly has pre-mined coins, so coins created at the Genesis block. At the block 0 there is already 1 billion coins, and those is the amount of coins that always are present in the blockchain. Other blockchains choose to create a coinbase, so start with 0 and then create as they go. In a proof of participation, the mechanics of creating new coins every block is the same like Bitcoin. So it starts with a bigger amount, and rather than halving every several years, is a very smooth curve. So it creates less and less every new block. But the difference is that because is a proof of participation, it rewards all the account that are participating in supporting the blockchain. So it's not like Bitcoin that the account that create the new block is the one collecting all the Coinbase. While in proof of participation, the Coinbase is distributed among all the accounts that are running the blockchain. And every block is elected who's going to be the next account to create the new block. And if this account for some reason is not doing its job, so it's not participating into the blockchain, then it's punished. So it's the opposite. Bitcoin rewards the one that create the block. Proof of participation punish the one that doesn't create the block when it's supposed to do it. Okay. And creating the block is a duty of any account that participate in supporting the blockchain. So there is nothing special about that to be rewarded, but it's important to be there and present when they're needed. That's it.
Oh, okay. And then can miners expect like a return on investment as a result of their activity in the blockchain?
This is like saying, if I buy a big printing machine and I open a printing shop, can I expect return of investment in the printing machine, right? It depends on the business that come along. So when somebody has a mining operation to mine Bitcoin, depends on the luck of being able to find the block before the others and winning. Statistically, it can be calculated. In other blockchain, like proof of participation blockchain, the coins are sort of guaranteed if a node behave. So there is more guaranteed to collecting coin. Then the coin need to have a value in the market, and this value has to be good enough to reward the investment done when running the node, whatever costs are involved in running a node.
Okay. And then for the DecBC project, how do you reward your miners?
DecBC work on proof of participation. Just the miners, which are not even called miners but minters. So these minters are rewarded by a distribution of the Coinbase among all the accounts that are elected to support the blockchain. So once somebody has a node, is running a node, and the node is online and it does its job, is guaranteed to collect Coinbase.
Okay. And how efficient is block reward in sustaining the operations of the network?
Well, I think that this is a very good point. So in a decentralized system, there cannot be one owner because that makes it decentralized. So once a system is decentralized, it should belong to those that run the system. So the rewards, so the payout for each node of the decentralized system should be the source of the income, let's say, for the work done by the nodes. Which means that in any decentralized system, this is a file storage system, let's say peer-to-peer network to store files, and we usually pay a monthly fee to every cloud system where we store files. If it is the centralized system, we pay this fee to the network, which means that this fee should be then distributed between all the nodes that are running the network, so that users have their service that they pay for on the centralized system, and those that are making the system possible are earning their own money, their income for the sales of the system. So there is no one central company that owns the system, but the system is owned by all those that are running it. So in the case of blockchain, the Coinbase is the reward for the operation that people does by running a node. So that's something that is organic in the blockchain itself, right? Else why would people run the node? That's the big question in Bitcoin, because all the Coinbase goes to a few companies, about 10-12 companies that collect all the Coinbase in Bitcoin, but there are thousands of nodes of the Bitcoin network that get nothing. So all these people are running node out of voluntary basis, or because they're running a service, let's say an exchange, rather than Block Explorer or something like this, but they are not making money directly from the blockchain. They are not rewarded for running a node to support the network, which is essential for the life of the network. This is one of the flaws that with proof of participation we wanted to fix, is the fact that the network is worth for the network itself. So all the nodes in the network should be rewarded for being there and support the system.
Okay. And my final question is, what are the weaknesses of the block reward system? And then what developers do to correct these weaknesses? Or
I think weaknesses are just on the logic on how this reward is distributed. So in the case of Bitcoin, in my opinion, the weakness is that this makes the whole operation of creating block very centralized. Just a few companies have enough resources or have a collective of people putting together the resources, but at the end of the day, very few accounts are the ones that decide all the history of the Bitcoin blockchain. So if they want to censor somebody, for example, an account is trying to spend some funds, they decide to never include the transaction from this account in any block. So this person has his funds locked, because just people sit at the table and say, hey, let's modify our software, never create a block including a transaction from this account. So censorship resistance is gone in a moment that a few people can decide what goes in blocks. Plus, doesn't have the means to support all the people running nodes that are essential in a peer-to-peer network to make sense of a network. Consider these people are not earning any Coinbase, any new Bitcoin, but they are doing at their own expenses. So this is something that needs to be fixed in the moment that the decentralized system rely on a peer-to-peer network. That's why we change from ICO, initial coin offering, to INO, initial node offering, because it shouldn't be the coin, the appealing part of setting up a network, but it should be the node, the appealing part on setting up a network. So once you have a node that is part of the selected group that is receiving rewards, then you're doing your part in making the service, the system possible, and then you are rewarded for that. That's the key part of all the system.
okay. And do you have anything else to say, before we conclude this session?
I want to say also that one of the key parts in consensus system is the fact that all the ones that are out there now, except the proof of participation, base their security on the financial aspect of running the network, right? So in the moment that a network is public, is correct, you need a Coinbase in order to motivate the people. And in the moment that there is a private network between a consortium of hospitals, hotels, whatever it is, there is no need to offer them a motivation based on Coinbase, because they are not there to make money for running the nodes, but they need the system to be secure anyway. So it's important to have mechanics that works independently from the rewards. So the security has to be there and calculated based on the participation in the network, independently of coins created.
Okay. Yeah, so that's all for our episode today on Block Reward. Like, if you have any questions, don't forget to leave. You can just write your questions in the comment section, in our YouTube video below. And then you can also suggest topics that we should talk about in our future episodes. And you can also leave your thoughts in the comment section. And then, like, if you want to send us an email, you can go to our website, to the contact page, where you will find out where to find us. So yeah, don't forget to subscribe to the channel, and then see you in the next episodes.